Hello and welcome. This is lesson 3.4, parallel lines and triangles. So today we're going to talk about theorems that relate to triangles that we actually get from parallel lines. So let's look at the first theorem here, triangle angle sum theorem. Very important theorem you need to add to your notes. This theorem says the sum of the measure of the three angles of a triangle is 180 degrees. Okay, let's correct that. Is the sum of the measure of the three angles of a triangle is 180 degrees. That is always going to be true. So that means if you take angle 1 of a triangle plus angle 2 of a triangle plus angle 3, it will always equal 180 degrees. Okay, so that's that theorem. Very important. You will use it often. Now, the second term we have for this lesson, we're talking about the exterior angles of polygons, and that's going to be all polygons, not just triangles. Okay, so let me draw a figure here. Let's get a square. All right, let's see. Let's get a color that's going to show up. Okay, here we go. So we have a figure there, and an exterior angle happens when you extend a side. Okay, if you extend a side, let's say we take this flat horizontal side right here. If we extend it, we create an angle right here that's on the outside of the shape. That's why it's called exterior angle, because it's outside. Okay, and that happens when you extend one of the sides, and you can do that all around the shape. That's just one exterior angle, but there are others. If we extend another side, we will see more, right? We can extend this one, it will create another exterior angle. Okay, so let's get this definition down. Exterior angles of a polygon. These are the angles that are formed by a side and the extension of an adjacent side. It's important to know however many sides the polygon or the shape has, that's how many exterior angles there are. Okay, so this figure over here is a square, rectangle, whatever you want to call it. It has 4 sides, so there are 4 exterior angles. Okay. Now let's talk about remote interior angles. Back to triangles now. Remote interior angles. Remote interior angles are the non-adjacent angles to an exterior angle. And I'm going to show you this. Okay, so specifically in a triangle, there will be there are 2, I can type well today, there are 2 remote interior angles for every exterior angle. And don't worry if this definition or the definitions are confusing. When we illustrate it with the figure, it will be more clear, okay? So I have a triangle over here. We know what an exterior angle is already, so let's create one. Extending, let's do a little bit nicer than that. So when you extend a side, we know that creates an exterior angle. So that's an exterior angle right there. okay? What's going to be considered remote interior? They are inside the triangle, but they are away from that exterior angle. They're not adjacent. They're not touching this one. So remote interior angles are the two angles inside the triangle that do not touch this exterior angle. And so that's going to be here and here. So these two blue angles are remote exterior angles to this red exterior angle, okay? So interior meaning inside, remote meaning away from. Remote interior angles are the two angles inside the triangle that are away from that particular exterior angle, okay? And this will happen 3 times in the same triangle, okay? So I could actually erase this and draw an entirely different example using the same triangles. Let me show you that. So let's extend right here, okay, and create an exterior angle out here, okay. Then the two remote interior angles for this one would be over here and over here. So it's just the two angles that are in the inside that do not touch that angle on the outside. Okay, that's remote interior. All right, now there is a particular theorem that goes with that information. It is called the triangle exterior angles theorem. And what that theorem tells us is the measure of each exterior angle of a triangle equals, always equals, the sum of its two remote interior angles. Okay, once again, that theorem tells us the triangle, the measure of each exterior angle of the triangle equals the sum of its two remote interior angles. So what does that mean? Looking at the same figure, that would mean that if this one is, if this exterior angle is, let's say 130 degrees, these two remote interior angles be 70 and 60. Okay. All I'm saying in this theorem is that these two remote interior, you add them because it says sum. When you add those, it always equals the remote exterior angle. So 70 plus 60, the two remote interior always equal that exterior angle that goes with it. Okay, that's what that theorem says. So make sure you have all of that and that example in your notes. Now we're going to move on to some practice problems. I will be doing the even ones today, and you'll be completing the odd. If you have any questions, make sure you post those under this video, send a message, or ask them in our group sessions, okay? Number 2 says find the measure of each indicated angle. And we have a triangle here and everything's on the inside. See that? It's not asking you anything about outside angles. So that means we're going to be applying the first theorem, triangle angle sum, because this is all about interior angles. Okay. And we can actually add that word in. The sum of the measures of the 3 interior angles is 180 degrees. Okay, so one strategy I like to use is to always write down the 3 items, 1, 2, 3, in an equation. So that would be 25 plus 120 plus question mark, you don't know, which I like to use X, equals 180 degrees. Okay, so we add what we know. 25 and 120 is 145. Plus X equals 180. And we just solve for x by subtracting 180 minus 145, and we will get 35 degrees for this missing angle. So that's our answer for number 2, 35 degrees, okay? Number 4, same process. You're gonna take the 3 angles that we know, use our triangle angle sum theorem, which tells us all 3 angles add to be 180. So 60 plus unknown equals 180. And yes, it is always 180. So remember that. 60 and 60 is 120. And once again, we just need to subtract to solve this. 180 minus 120 will let us know that this angle has to be 60 degrees. So that's our answer for number 4. All right, that completes this section. You will need to use the same process to solve problem 1 and problem 3. All right, in this section, we are solving for x, but notice once again, we are still using interior angles. All of the figures have angles in the inside. So even though we've stepped it up just a little bit, we're still only using the first theorem, triangle angle sum theorem. All 3 angles add to be 180, okay? I'm gonna do number 6, but just to point out in number 7, you see 2 pieces of information in a red box. So they did give you all 3. Just make sure you know red box has a value. You should remember that, okay? Let's do number 6. 1, 2, 3, add to be 180. So 25 plus 140 plus 2x plus 3 equals 180. Now this equation is a little bit longer, but that's okay. We're going to solve it by combining all of our regular numbers first. So we want to add 25, 140, and 3 together. They're like terms because they do not have a variable. So 25 and 140 is 165. Plus 3 more gives us 168. Bring down 2x equals 180. Okay, and then we just need to solve this equation and subtract 168 on both sides. And that will give us 12. So 2x equals 12. Divide both sides by 2, and x is 6. And that's all they asked us to solve for this time. Okay, so we're done with number 6. In the next section, find the measure of each indicated angle. Now look at the figures this time in this section. They're different. We have outside angles, which we know are called exterior angles. We know this because a side is extended. Look, this side of the triangle is longer and it's creating this exterior angle. All right. So in this case, we're going to use the other theorem, triangle exterior angles theorem, that tells us that outside angle is equal to the sum of the 2 angles on the inside that are away from it. Okay. So let's look at number 8. When we set up our problem, once again, we know the outside angle, which I have been using red for, is equal to the sum of the 2 remote interior angles. And I've been using blue for that. These are remote because they're away from the outside angle, but they're interior because they're inside the triangle. And when you add those up, it should always equal that exterior angle. So 55 plus unknown. Okay. That's how you would set that up. 55 plus x equals 113. When you solve this, you're just subtracting. And this unknown value comes out to be 58 degrees when you subtract. Okay, that's the answer to number 8. You will do number 9 the same way. Same way. Red is equal to blue plus blue. Okay, same thing. Let's move on and do the last few problems. Number 10. Here we have a figure. We have more than one exterior angle showing, but there's only one we have information for. So let's look at that one only. This one is the only exterior angle that we have a value for. This one we don't know anything, so it's no point in using that. Okay. This exterior angle goes with these two interior angles, remote interior angles. So our setup this time, we take the 133 plus the unknown is going to equal 153. And we just subtract to solve this. 153 minus 133 is 20. So this unknown value, the answer is 20 degrees for that angle. Okay. Number 11, you're going to do the same way. You see two exterior angles. There's only one that's worthwhile, so only use that one, okay? All right, just two more and we will be done. This time we're solving for x using the same theorem. How do I know it's the same theorem? Because look at the figure. I have an extended angle on all of these. I have remote interior angles for all of these. So it's the same process, just a little bit elevated. So for 12, I'm identifying my exterior angle in red, my two remote interior angles highlighting in blue. I know I add the two blue ones and it will equal the red one. So 15 plus 5x plus the other inside angle is 5x minus 7 equals, I was trying to change the color here, but it looks like it's going to change the whole thing. That's fine. Equals 118. Okay. And now we need to solve this. We first need to put together anything that does not have an x, so 15 and negative 7. You put that together, you get an 8. And 5x and 5x, or excuse me, yeah, 5x and 5x is 10x. So 10x plus 8 equals 118. Solving this, we'll subtract 8. We get 10x equals 110. Divide both sides by 10, and x is 11 for number 12. X is 11 is our answer. Once again, we just took the two blue inside angles, add them together, set it equal to the exterior angle. Okay. And then you solve whatever equation it ends up being. Number 14, last one, we're going to take this exterior angle. It equals to the two remote interior angles. So our equation will be 7x plus 2 plus 80 equals 26x plus 6. Okay, still just need to take it one step at a time, combining terms that go together. So 80 and 2 makes 82. 7x didn't have anything to match with. And over here on the right side, I can't combine anything because one has an x and the other one doesn't. Okay, so this is where I am right now. So I have x's on both sides. I have numbers on both sides. I like to move my x's first That's just me. I like to move the smaller x, so I'm going to subtract 7x on both sides. And that's going to leave me with 82 over here, right? Because those 7's cancel. 26 minus 7 is going to leave me with 19, I believe. I'm just going to check myself real quick. Yeah, 19x plus 6. Okay, subtracting 6 on the other side. Okay, 76 equals 19x. And divide both sides by 19. And x is 4. That's our answer for 14, okay? So guys, that is the lesson on 3.4, parallel lines and triangles. We talked about some vocabulary, but 2 very, very important triangle theorems. That is the triangle angle sum theorem and also the triangle exterior angles theorem. Please add those to your notes. Bring your questions to your sessions or type them as comments to this video. Have a great day.